a 3.5 kilogram block is pushed along a horizontal floor by a force of 15 newtons. So this is 15 newtons. And the block, the coefficient of kinetic friction between the block and the floor is calculated to be 0.25. That's a constant value. Calculate the magnitude of friction exerted on the block and the acceleration of the block. But before that, let's make a free body diagram. Now, this block is on a surface. When it's on a surface, we have what we call the normal force. The normal force is always perpendicular to the surface. The next one is the force that is always present. It's always present and it's going down. And that is the gravitational force, or simply the weight, which is mass times gravity. Next, we have the friction. So the friction is opposite to the object's movement. So here is friction. And the next one is the force. This force, which is 15 newtons. Now, that force will actually appear here. And that can be written in its component form. We have here 40 degrees. So if this force, F, is equal to 15 newtons, let's just say F first. So this force is F cosine 40. And here, F sine 40. Now, we have written it in its component form so that we will be solving along the x, along the y, and along the x value. It would look like this. We want this to be written in its component form, the x and the y form. So we write it this way. So first, let's talk about the y-axis. Now, the summation along y-axis is composed of a positive Fn, because this is a positive x, a positive y, and it's negative y's. So, a negative Fy minus weight. And this is equal to 0. Why is it equal to 0? Because it's not moving up and down. So it's at rest in the y direction. So that would be 0. Now, I think we've talked about the value of Fy. That's 15 sine 40 degrees. Weight is mass times gravity, mg. The mass is 3.5 kilograms. And the gravity, of course, 9.8. And we have here Fn is equal to 0. So this would be Fn minus 9.64 minus 34.3 is equal to 0. Let's add those values. 43.94 is equal to 0. Or simply, Fn is equal to 43.94. Why do we look for normal force? Because friction has a formula of normal force times the coefficient of friction. Now we know that this is 43.94 and we have the coefficient given here, 0.25. So the friction now is 10.985 or simply 11 newtons. So this is our friction. Next, we're looking for the acceleration. Now, what is the value of acceleration? We will get that by getting the summation along the x-axis. So this is the summation of forces along the x-axis. That is a negative value of friction and a positive value of the Fx. We have here Fx minus the friction, and that is equal to, guys, this is the total forces along x-axis. It's very different from this one, okay? The total of this is ma, mass times acceleration. Again, the total of this is ma. Why? Because we have now acceleration along the horizontal. So it's no longer 0. Our object is moving in the x direction, not moving on the y direction, but just on the x direction. So we have an acceleration there. So Fx is given, that's 15 cosine 40. Friction, we've computed friction. We have computed that's 10.985 98.5, or simply let's go for 99 or 11 if you want to, is equal to the mass. Mass is 3.5, and now we're looking for the acceleration. So let's solve for that one. 15 cosine 40 minus 10.99 divided by 3.5, that is our acceleration. Hence, our acceleration is 0.14 meter per second squared. Acceleration along the x-axis. So this is our answer.